In this video, we're going to start working with multiple logistic regression. And to do so, we're going to be working with this data set that I'm going to refer to as the low birth weight data set. Now this is a data set recording if a baby was born as low birth weight, yes or no, and a bunch of explanatory or X variables. So first, let's import that data set into R. We can take a look at the names of the variables. And let's go through an explanation of what each variable is. So the first variable, low, is our Y or our outcome variable. And this is an indicator if the baby is low birth weight, 1 for yes, 0 for no. Age is the age of the mother in years. LWT is the mother's weight at last menstruation, or roughly weight at conception in pounds. LWD is an indicator if the mother's weight is less than 110 pounds, 1 for yes, 0 for no. And don't mind that typo where mothers is missing the apostrophe. Too late to go back and correct that now. Race is a variable recording the race of the mother, categorized as 0 for white, 1 for black, and 2 for other. Smoke is an indicator if the mother smoked during pregnancy, 1 for yes, 0 for no. HT is an indicator of a family history of hypertension, 1 for yes, 0 for no. UI is an indicator if the mother has a presence of uterine irritability, 1 for yes, 0 for no. FTV is the number of visits to a physician in the final trimester. PTL is an indicator if the mother has had a previous premature labor, 1 for yes, 0 for no. And finally, BWT is the birth weight of the baby in grams. So this could be an alternate Y variable that we can work with. We're not going to want to include this in any model, right? We're not going to use the baby's birth weight to try and predict if they're low birth weight, yes or no. Hopefully you can see the problems with doing that. So let's quickly look at a summary of the data. And you can probably notice here, all of the variables are being recognized by R as being numeric or integer. Right? For example, family history of hypertension, we're getting means and medians and things like that because it was coded with ones and zeros. So the first thing we should do is go and make all the categorical variables into factors in R. We're not going to do this for the outcome variable of low, but we'll do it for all other variables. And in previous videos we explained why we leave the outcome as a integer 0, 1. So here, I'm going to ask R to go into the low birth weight data, find the variable LWD, and replace it with, as a factor, that variable. Okay, so it's going to convert it into a factor. Let's do that for LWD, for race, smoking, and all of the other factors or categorical variables that we have. Now we can see if we check summaries of the data, we're now getting frequencies. For example, there were 30 individuals who've had a previous premature labor, 159 who haven't. So let's go ahead and attach that data. And in previous videos we've talked about the pros and cons of attaching. We're working with attaching mainly for teaching purposes. So a reminder through our course, we've been talking about building effect size models versus predictive models. So an effect size model might ask a question like, what effect does smoking have on the probability of a baby being low birth weight? Does it increase that risk, and if so, by how much? Our predictive model really seeks to just get a good guess at what the outcome might be. So what is the probability of baby's low birth weight, and what variables are good predictors of that? For now, we're going to look at fitting a logistic regression model and interpreting some of its components without really picking a research question and just talking about how do we fit the model, what are the interpretations of its coefficients, and so on. We'll get to building models later. So first, just a reminder that really you should examine the data before you get into model building. All univariate summaries, lots of bivariate summaries, especially the relationship between all variables and your outcome variable, as well as all variables and your explanatory variable of interest if you're building an effect size model. So at some point we're going to get to building a model trying to estimate what effect does smoking have on the risk of low birth weight. And we'd want to examine what relationship all variables in our data set have with smoking. Let's quickly just take a look at a few summaries just to get a feel for the data set. So the first is we can look at a table of our outcome, low birth weight. Here we can see in our data set, 59 babies were classified as low birth weight, 130 were not. If we calculate the mean of low, we can see that the mean is 0.31, or this tells us 31.2% of babies were low birth weight. We could also calculate that manually from the table, right? The 59 that were low birth weight divided by the total, or we can also use the prop.table table command to get those. Again, we can see 31.2%, or about a third of the babies were low birth weight in this data set. So let's get to fitting a model, and we're going to use smoke, LWT, age, and race to try and estimate the probability of a baby being low birth weight. And we're going to fit this model for the sake of demonstration. So we're not saying that this is a good model right? We haven't even identified a goal for this model or what a question we are asking might be. We just want to take a look at fitting a model and interpreting some of its components. So let's go ahead and fit that model here. I'm going to call it sake of discussion. Right? We pointed out we're going to use GLM to fit a generalized linear model. We're going to estimate the low birth weight using smoke, age, race, and LWT. And finally, we specify that family equals binomial, and this is the way of letting R know that we want to fit a logistic regression model. So let's fit that model. We can ask for a summary of the model, and we can see that summary here. If we wrote an expression of the model, it would be that the log odds of low birth weight are 0.322 plus 1.05 times the indicator if the mother smoked during pregnancy, minus 0.022 times the mother's age at conception, plus 1.23 if the race is 1 or black, plus 0.943 if the race of the mother is 2 or other, minus 0.0125 times LWT, or the mother's weight at last menstruation. So what we're going to do is we're going to go to a video where we work with this model. We're going to ask and answer some questions using this model, and then we'll come back to another video where we're going to answer the same questions but looking at how we can get R to do those calculations.